Okay. All right, I'm ready to get started so that you guys have enough time to get started on your homework for today. This is a review. What is the solution to a quadratic equation? Beginning of our notes from last class. We remember things we write down, so write it down again since nobody knew what that was right away. Where the graph crosses the x-axis. The two are the points where we cross the x-axis. What are those called? Yeah, yep. Those are roots. So another word for x-intercept, yep, roots. And we wrote this last time. Another word that you might see, and I didn't mention this to you, another word is zeros. So again, all these things mean the same. Solution, x-intercept, roots, zeros. Those are all the same exact thing. To find the zeros of a quadratic equation in factored form, set each of the factors equal to 0 and solve for x.
So I need to put my keys in your hand. So can I get your keys and bring them back? I gotta print myself.
Thank you. Only that printer is working. I had to run around this morning.
Which? The one in the office? You want to want it somewhere? How do I send it? Can you send it?
To print?
Yeah, because I emailed it to you. Because I just sent it to B101. Can you print 2?
Yep.
Thank you. I'll probably get you up the first one. Okay. Does that work? Just because today, I already sent all these. But hey, next time, because we'll be doing this, we'll be doing it 4 times. All right. Sorry to interrupt your class, guys. Later. Bye.
Okie dokie, back to the notes. So to find the solution set, it says that we need to set each factor equal to 0 and solve for x. So that's what we're going to do. We're going to set each factor equal to 0 and we're going to solve for x. So these kind of split, and this is also called the zero product property. It means that when you have two things, or when you have things and they're being multiplied and they're equal to 0, you can set them equal to 0 and solve them. So I get x plus 15 is equal to 0 and x minus 2 is equal to 0. And these will always be simple 1, maybe 2-step equations at this point. So x plus 15 is equal to 0. We have to subtract 15 and we get x is equal to negative 15. And x minus 2 is equal to 0. We need to add 2. So we get x is equal to 2. So I can list my solutions. I get x is equal to negative 15 and 2. The next one, it's the same thing over and over again. I'm going to split them and I'm going to set them both equal to 0. So x minus 2 equals 0 and x plus 9 equals 0. So I will add 2 and I will subtract 9. So I get x is equal to -9 and 2. I don't care if you write it either one of those ways, just do not put parentheses. Parentheses is not correct. Questions so far? Yes. That's like standard to put the negative first. I would not count it incorrect if you put them in, if you switch the order, because it's just a list. It's not an ordered list. But if you're checking answers, it's going to be easier to check when they're in that order. If you're looking for a multiple choice, they're going to be in that order, but it's not wrong. So I'm going to count off a point if you put parentheses. That's wrong. If you switch the order, that's not wrong. It's just not standard. And the last one, do you guys see a pattern here? These are kind of easy, right? Do you think you could even do it without writing it out? What do you think that the solutions are? -1, and it could also be written like this. Sometimes they're written out where it's x equals both times. I just want you to see the way that you might see answers. So just like that we use different words to describe the same thing, solutions, x-intercept, roots, zeros, sometimes the answers look a little bit different, but they're all describing the same thing. Are we good so far? Do we think this is easy, just like the graphs? I hope so. This is easy. This whole front page should be easy. All right, so we're going to continue doing this. Some of them are super simple. So looking at question number 4, and this says 0. Zeros are the same thing as x-intercepts. You're splitting them, setting them equal to 0. So I know, and it's really easy to see that this one, I know that x is equal to -7, right? That one's easy. The other one, I would like to see you guys write it out because there's more steps. So we get 2x minus 2 equals 0. So we need to add 2. And then I will divide by 2. So x is equal to 1. So x is equal to -7 and 1. Again, I would really like for you guys to write it out when there's something other than just 1 in front of the variable, because I can almost guarantee that you're going to make mistakes if you try and do those in your head. For question number 5, yes, x is equal to -3. That one's easy. The other one, I want to see you write it out. 3x minus 6 equals 0. You will make a simple mistake if you don't write it out, I can almost guarantee. So we get x is equal to 6 divided by 3 is 2. So our solutions, x is equal to -3 and x is equal to 2. Again, I'm just writing the answers a variety of different ways. I want you to know that they're all the same. Question 6, what is the answer? It's just 1, right? So you might do something and it might list it twice, or it might just list it once. You don't have to list it twice. You can, and you might see it listed twice, but it doesn't have to be listed twice. It's not wrong if you don't list it 2 times. Yeah, quick. Oh, I didn't know if you still needed it.
No, I have my badge. My keys are.
All right, for questions 7, 8, and 9, I'm going to work them up on the board. I want you to work them on your paper. Let's just make sure that we know what we're doing. They're not difficult. Just let's make sure we know what we're doing. So you work them and I'm going to work them. Did y'all get the same thing? All right, so if you have factors, you can figure out what the zeros are. Is that a yes? That's what we just did. Okay, so there is a difference. I want to point that out to you. So these are factors. And this is a zero, a root, a solution. Okay, those are factors. Remember, factors are things that multiply together. So basically, if we can get to factored form, finding the zeros is easy. Finding the solution is pretty easy. If we can get to factored form, that's why we talked about factoring last class. If we can get factors, we can set them equal to 0 and we can solve. The next thing that we're going to talk about are perfect cubes. Last time we talked about perfect squares. So on the quiz, on the test, you will have a formula for the sum or difference of cubes. You don't have to memorize this. You do have to know the format for a difference of perfect squares, but not for sum or difference of cubes. So first thing that I want to do is get a list of perfect cubes. So let's start with 1. Perfect cubes are things multiplied by multiplied 3 times. So 1 times 1 times 1 is just 1. What about 2 times 2 times 2? Two times 2 is 4. 4 times 2 is 8. What about 3 times 3 times 3? So 3 times 3 is 9. 9 times 3 is 27. Okay, so 4 times 4 is 16. 16 times 4. Use your calculator if you need to. Okay. What about 5 times 5 times 5? I really doubt you're going to see numbers bigger, but let's go ahead and do 6. What's 6 times 6 times 6? So just like perfect squares, you're going to have only 2 terms. And something's going to be cubed. So in this case, we'll have something cubed plus something cubed or something cubed minus something cubed. And then we've got a formula. So for the first one, is 27 a perfect cube? Yes, so we can rewrite that. That's the same thing as x cubed plus 3 cubed. And all I'm going to do is use that formula and I'm going to rewrite it. So I get x plus 3. And then it says the first position squared, so x squared, minus the 2 numbers multiplied together, so 3x, plus the last position squared, so 3 squared. That's it. I have to teach you that formula, so I'm teaching you the formula. Are you going to have a whole bunch? No, you just now we're doing 2 of them. You just need to know how to use the formula. The next one, 8 is a perfect cube. And we're going to use the formula. So the formula says that it should be x minus 2. And then I will have first position squared, so x squared minus the 2 things multiplied together, so 2x. And then the last position squared, so 2 squared. Again, you don't have to memorize the formula. I would like to point out that just depending on what you're looking at, it is possible that that is written as 9. It is possible that that is written as 4. Let's say if you're looking at a multiple choice something. I believe you only have like 2 questions maybe on your homework that have those. It's not very many. Are we good so far with the front page? Why are you thumbs down? All it is a formula. It is just a formula that if you are given something and you're told to factor, we haven't done anything with cubes, right? Nothing cubed. Okay, so they're different, right? They're different. And I'm giving you a formula. So all you have to do is to be able to write whatever that term is as something cubed. And we have a list. It's not going to be a very high number because they get really big really fast. Do you guys understand how I did this step where I just rewrote it as something cubed and something cubed? Okay, so then the next step was just me using that formula. So it said the first position, so that's the first position, that's the second position. So A plus B, so it would be X plus 3. That's all that goes there. And then this is just a formula. So it says the first position, whatever number that is, it's going to be squared. So there's an X, so it's X squared. In the middle, it says I'm going to minus, okay, minus. And then it says the two things that are in parentheses, you multiply them together. So I have X and I have 3, so that's 3X. So all I'm doing is taking the stuff and plugging it into the formula. That's it. So the first position is A, second position is B. So you're not solving anything. You're just using a formula. Does that make more sense? Okay, good. And so all you have to do is if you're adding, you use the sum formula. And if you're subtracting, you would use the difference formula. And again, I would never expect you to memorize those. I would give them to you. All right, last class, I remember that I talked to you guys about we were going to have the gender reveal. So we did the gender reveal and it's a girl. We're having a girl. Well, not me, but it's going to be my baby anyways. So they're going to have a baby. It's going to be in March. I'm super excited. Yay. All right, on to the back. Notes. I know, crazy, right? Do what? Yeah, my son is, he's only 20, so yeah, I don't have any more. All righty, on to the back. We are going to factor trinomials. This is something that you were supposed to learn in Algebra 1, but I know that the struggle was real. So we might be learning it for the first time today. Factoring trinomials. So a tri means 3. It means you've got 3 terms. 1, 2, 3. These are all factoring when you have A is equal to 1. It's different when A is not equal to 1. So today, all we're doing is when that first term, that leading term, the coefficient is 1. It's easier to factor. I call it fast factoring because it's fast, it's easy. Once you learn it, it's fast. It will be fast. So again, this is when the leading coefficient is 1. So our first step is to always make sure that the equation is equal to 0. If it's not, we got to fix it. So we can't factor these unless we have them set equal to 0. So looking down, that one is equal to 0. That one's not. So I'm going to have to bring the -8 over. That one is. Okay, so that's that first step. You got to make sure that it's equal to 0. Next thing that we're going to do is check for a GCF. They don't always have a GCF. Sometimes they do. The next thing that we're going to do is list factors of A times C. Well, in this case, since A is 1, it's always going to be 1 times the last number. So C is that position. So see how this is the formula or the format? That's just a formula for a quadratic. So we're going to list factors of 36. So list factors of A times C. So it's like 1 times whatever that last number is. Next thing that we're going to do is find a factor pair that can be put together to make B. And I'm going to go through all this with you. Once we do that, we'll put the pair into the factors. So the factors will always set up as X, and then we put the numbers in. The B term is going to determine the sign of the bigger number. So whichever one of these is bigger, you're going to look at that B term. If it's positive, then the bigger number is positive. If it's negative, the bigger number is negative. And once we figure out what the bigger number is, we can figure out the smaller number. That's a lot, so let's go through it. The more times we go through it, the more you'll get it. So our first step, we gotta check, make sure it's set equal to 0. It is. Now we're going to list factors of 1 times 36. It's just 36. So factors of 36. I usually just start at 1. 1 times 36, 2 times 18, 3 times 12, 4 times 9. Can you think of anything else? Eight does not go into 36. So sometimes you don't have to have a complete list. Sometimes you can just make a short list and you've already found your factor pair. So what we're doing is we're looking for a pair. So you have to multiply the first and last. That gave me 36. So I'm looking for one of these pairs that I can put together. And I didn't say add because sometimes it's not adding. I need to combine them or put them together to make 13. So it's like 36 minus 1, nope. 36 plus 1, nope. Okay, 18 plus 2 or minus 2. So do we have a pair in here that I can put together to make 13? 9 and 4. So that's my factor pair. Once I find my factor pair, I'm going to set up my factors. And so I'm going to go take my factors and I'm going to put them in there. It doesn't matter where I put the 4 or where I put the 9. I just need to put them in there. Now it says that the middle number or the B, so the B is always the middle number. The middle number is going to help me determine what the sign of the bigger number is. So that's positive. So that's also going to be positive, or they're both adding, they're both plus. To figure out the sign of the other one, I have to start with this one. So if I have positive 9, would I add or subtract 4 to make 13? Add. So the other one's got to be a plus. That's it. I was looking for a pair of numbers that would make 13. So what you do is you're looking for factors, so things that multiply to give you 36, but it's not technically, so you have to know that you could add a negative. So it's things that can multiply to give you the last number that could add to give you the middle number. But keep in mind that adding could be adding a negative. Let's do more. So once we do more of these, you'll kind of start getting the hang of it. The second one is not set equal to 0. So I need to make it set equal to 0 first. So I'm going to have to bring over the minus 8 and add 8 x. And I need to put it in the right position. So it's always going to be the squared term, then the not squared term, and then the term without an x at all. So now I have a trinomial set equal to 0, and I'm going to look for factors of I'm looking for factors of 1 times 15. So yes, factors of 15. There's not a whole lot of them, 15. So I've got 1 and 15. 3 and 5, yeah. And so once I get some factors, I have to look for the factor pair that can be put together to make 8. Yep. So I'm going to go take and put those in there. Doesn't matter which order that you put them in. So now I need to look at my middle term. My middle term is 8. It's positive. So my bigger number, which is 5, needs to be positive. So if I have positive 5, would I add or subtract 3 to make positive 8? Add. So basically, anytime that you have terms and they're all positive, like that's all positive. If you don't have a negative in the problem, you're not going to have a negative in the answer. You're just not, because there isn't any negatives. So it's easy, especially when they're all positive. You don't even have to worry about the signs. They're both going to be positive. Okay, let's do another one. What do you think we should do? Haley is right. So we got a GCF. See how they're all divisible by 2? So anytime you don't have a leading coefficient of 1, you need to make it 1 because then you can fast factor. And so most often you just need to divide out whatever is first, and then you'll have leading coefficient 1. So in this case, they're all divisible by 2. So I can divide by 2, divide by 2, divide by 2. It would be still 0. Okay, now I'm going to factor the stuff that is inside. The 2 is along for the ride. Don't lose it. So in my answer, I'm still going to have a 2 out front. So now I'm looking for things. I can multiply 1 times 13 and don't ignore the negatives. Don't mess with the negatives yet. So I'm just using the values. So 13. So factors of 13. 1 and 13, pretty short list, right? So that narrows it down. So we're going to have 1 and 13 in here. And like I said, don't try and worry about the positives or negatives yet. So the rule is that you will always look at that middle term. So that's negative. The bigger number has to be negative. So that's where I start. So that has to be a negative 13. So if I have negative 13, would I add or subtract to get to 12? Add. Very good. Anytime you're dealing with negatives, you always want to just double check because these two numbers should be able to multiply to give you the last one. So would a positive times a negative give you a negative? Yeah, so that's good. You did the signs correct. Good job. Okay, we've got more factoring. So we're going to continue to factor these. The first one, it would be, it's leading coefficient 1, so I can start factoring. 1 times 121. Okay, so we're looking for factors of 121. Okay, there might be more, but that's the first one that comes to my mind. Would that one work? Can you put those together to make 22? Yeah, so that one will probably work anyways. So I've got my factors. All right, so my middle term is negative, but they're both the same value. So which one gets to be negative? Both of them, because they're exactly the same. So will negative 11 and negative 11 add to give me negative 22? Yes. Will negative 11 and negative 11 multiply to give me positive 121? Yes, then we're good. I do want to show you that this will a lot of times be written like this because it's the same value twice. So it means the same thing. So I want you to write it both ways. For question 16, can I fast factor? Fast factor means leading coefficient is 1. That's a no. So I'm going to see if I can divide out the 3. Are they all divisible by 3? Yeah, then let's divide it out so that we can fast factor. So now Yeah. Thank you. No, not 6, not 6. Yeah. Yeah, it's 36 divided by 3, so it's 12. So we're going to look for factors of 1 times 12 or 12. So 1 and 12, 2 and 6, 3 and 4. Which one of those factor pairs can put together to give me 7? So I get 3. What are the signs going to be? Both positive because the whole problem is positive. Okay, I forgot that the directions say find the solution set. So remember, these are factors. These aren't solutions. These are factors. So to get a solution, remember you just set them equal to 0. So for question 15, if I set x minus 11 equal to 0, what is it going to be? X minus 11 is equal to 0. So what does x equal? 11. When you add 11, you get 11. So this is my solution. And I don't have to do it twice. So the solution is x is equal to 11. For question 16, if I set each one of these equal to 0, so you even have to set the 3 equal to 0, but what is 3 equals 0? It doesn't really matter, right? 3 equals 0, does that even make sense? So you can ignore that one because it's always going to be, it will always be like that. It will always be like that. So yes, my solution is equal to -3 and -4. I wrote them in not numerical order, but that's okay. So remember when you set them both equal to 0, they always become opposite. So I believe I heard, ooh, I don't know how to do the last one. Yes, you do. We got to set it equal to 0. So we will subtract x and we've got to put it in order when we do that. So I'll get x squared minus x minus 42 is equal to 0. And so 1 times 42, I'm looking for factors of 42. 1 and 42, I know it's divisible by 2, so 2 and I don't think 3 goes in there. What about 4? 4 won't. 6 times 7. So we're looking for a pair that if we put them together, we would get 1. So the two numbers have to be really close together. Yep, 6 and 7 will work. Okay, so looking at that middle term, the middle term is negative, so the bigger number needs to be negative. So 7 has to be negative. If I have -7, would I add or subtract 6 to make -1? Add. Okay, but remember that this is just factoring it. Once we factor it, we can get our x's. So x is equal to what and what? Very good. Okay, so you have some problems on your homework where I just asked you to factor. You have some problems on your homework where I ask you to factor and then find the solution set. So finding the solution set is really easy once you have factored. You need a brain break? That? No. Nope. I got it when I graduated college. $9.58. Not yet. All right, we've got one last section and then you'll have time to get started on your homework. The last section is factor by grouping. And so this works the exact same way that we did our homework last time. The only difference is we have things that are cubed. That's fine. We can still factor by grouping. So factor by grouping. We're still going to have our two groups. So we're still going to have our two groups. And you can also double check kind of looking through there if the signs are in the same position. So I have plus, minus, and then I have plus, minus. So I don't have to worry about factoring out a negative or anything. So factor by grouping says that I'm going to look for the GCF in both groups. So for the first group, what would my GCF be? Definitely a 2. Yep, so I heard somebody say it, 2x squared. It's exactly the same. There's just cubes now. So the 2 goes on the outside. The 2x squared. And then I write down what I have left. So that would make this just x. And then minus, yep, 4, just minus 4. Remember, so my goal will be the second parentheses should be x minus 4. If I'm doing this correctly. So my next GCF. Yep, I agree. And I'm dividing out a positive 3. So it would be positive 3. That will be x and minus 4. Good, good, good. That's what I wanted. I wanted 2 parentheses that are exactly the same because that's a new GCF. Both of those terms have an x minus 4. So I write it out in front. And then I write down what I have left. 2x squared plus 3.
Does it matter which order you put it in?
No. Any questions over the first one? That's it. The next one, remember that we always want to make sure that we scan through and check for a GCF. So usually if there is a GCF, a lot of times it's that leading term, but not everything is divisible by 3. So this one doesn't have a GCF, but I can still break it up. So anytime you have 4 terms, you're factor by grouping. So I'm going to look at my first group. What would my GCF be? Yep, so I pull that out front. So I'm left with X and then plus 5. So our goal is to get the second group should also have an X plus 5. So this one's interesting because what is the GCF of the second one?
1.
Yeah, it's just a 1. So I would divide by 1, and it's a positive 1. So when I put positive 1 outside, I'm left with X plus 5. So again, my goal is to get parentheses that are identical because that's actually a new GCF that I will put out front. And then write down what is left. Question 20.
Take out a 4.
What do you think we should do for question 20?
No, you can divide them by 2. I know by 4.
You can actually divide everything by 4. He's right. And so I'm going to pull that out front. What would happen is that like in this pair, it would be like you end up with 2x minus 8, and you could have pulled something else out of one of the factors. Nope. Did y'all get the same thing for the first step? So we're going to go through and we're going to break it up. Now we can do our grouping.
So you would put the X squared 4.
No. So Vance asked, do you put the X squared with the 4? No. Everything that's in parentheses stays in parentheses. The 4 is on the outside. So for the second grouping, remember our goal is to get X plus 2. So what would we factor out? Yes, we have to pull out a 2, but if you look at the signs, these are both positive and these are both negative. So they have to be the same. So you have to pull a negative out of the second grouping. Okay, then you're left with X plus 2. All right, so our goal was to get 2 factors in parentheses that are the same. We did. So I will pull that out into the front.
What would it look like? You would still have the 4 out of it, right?
Yep. And we have one last problem. So what if you try and do the last problem and I'll do the last problem? We make sure we get the same thing. What? Did y'all get the same thing? All right, you guys have about 20 minutes to work on your homework. I would make good use of my time. You have people here that can help you, so get started on your homework.